Hello children, welcome to my channel. Today's topic is reflection, chapter number 12, class 10. Okay, this is part 1. From class 9 you already know about x-axis and y-axis. Suppose this is x-axis, look at here. This is x-axis, this is y-axis. Okay, so when these two lines intersect each other, they form a plane. Okay, you can see this is a plane. This plane is called xy plane or Cartesian plane. Okay, I have already told this in class 9. Next, you know how to plot points. For example, I want to plot 2, 3. Okay, I want to plot a point whose coordinates are 2, 3. Then this is 2. First x-axis. Okay, first x coordinate, then y coordinate. Suppose this point is A, whose coordinates are 2, 3. Okay. Let us plot one more point, whose coordinates are -3, 2. -3 and 2. So -3, 2 means here. Okay. Suppose this point is D. -3, 2. Let us plot a point whose coordinates are 4, -2. 4 and -2. 4 and -2. Suppose this is C. 4, -2. So in this way, points are plotted in the graph. Imagine that this is the graph vector. Okay, I don't have graph vector. I am using the board. Now we have to understand what is x coordinate and what is y coordinate. Okay, I have already told you in class 9. Again, I am explaining. See here, the x coordinate of A is 2. Okay, the x coordinate of A is 2. Now, what is the distance of A from the y axis? What is this distance? This distance is 2 units. Okay. What is the x coordinate of C? 4. What is the distance of point C from the y axis? This distance, which is, you can see this is 4. So from this we can understand that x coordinate of the point is the distance of the point from the y axis. So remember this. X coordinate, it is also known as abcissa. Okay, x coordinate or abscissa. What is this? Distance of a point from the y axis. Okay, so remember this. X coordinate is also known as abscissa, and what is it? It is the distance of the point from the y axis. Now let us go for y coordinate. Okay, let us go for y coordinate. Y coordinate is also known as ordinate. Let us see what is it. See, what is the y coordinate of A? 3. What is the distance of A from the x axis? Let us see. This is the distance of point A from the x axis, which is 3 units. You can see 3. So y coordinate means distance of the point from the x axis. Similarly, see here, the y coordinate of C is -2. Okay, let us see. Suppose B. The y coordinate of B is 2. Okay. Now, what is the distance of point B from the x axis? That means this distance. This distance is 2 units. Okay. So remember, y coordinate or ordinate is the distance of a point from the x-axis. So it is very easy to remember. X coordinate is the distance of a point from the y-axis. Y coordinate is the distance of a point from the x-axis. Okay, it is very simple. You have to remember that this is the basic of coordinate geometry. Okay, first you have to understand this. Next, every line is represented by some equation. Okay, every line has some equation which we will study in the chapter number 14. Equation of a line we will study in detail. But for the time being, just remember in class 9 also you will study that every line has an equation. Okay, every line is represented by a linear equation. So let us take one equation. X is equal to 0. Let us try to find out whose equation is this. It must be the equation of some line. Okay. Now let us find whose equation is it. X is equal to 0 means x coordinate will always be 0. So let us take some points. Let us take some points whose x coordinate is 0. For example, 0 0. Okay. 2 0. 3 0. Sorry. X is 0. Sorry. X will be 0. So 0 0, 0 1, 0 2, 0 3, 0 4, 0 minus 1, 0 minus 2, 0 minus 3, 0 minus 4 in this way. So if you want to satisfy this, you have to take x coordinate 0, y coordinate may be any value. Okay, you take any value for y, but x equal 0. Okay, so if you plot those points, you will get this line. This line. But what is this line? This is the y-axis. Okay. So remember this, x equal 0 is the equation for y-axis. Okay. Next let us move to y is equal to 0. We have to take now y is 0. Okay. Take different points whose x coordinate may be any value but y coordinate will be 0. For example, 5 0, 3 0, 2 0, 1 0, minus 1 0. Minus 3 0, minus 4 0, minus 5 0. That means you are getting this line. When you take y is equal to 0, you are getting this line, the horizontal line, which is the x-axis. Okay. Now see, if I take any point along the x-axis, its y coordinate will be 0 because its equation is y equal to 0. But x coordinate may be any value. Okay, we cannot see. So any point in the x-axis is of the form k, 0. Remember this. Okay, you take any point. For example, 5, 0, 2, 0, 4, 0, minus 1, 0, minus 3, 0. So any point in the x-axis is of the form k, 0, where k is a constant, k is a real number. Similarly, if you move to the y-axis, its equation is x equal to 0. So x coordinate will be 0. X coordinate will be 0 definitely. Let us go for the y coordinate. Let us take some points. 0 4, 0 3, 0 2, 0 1, 0 0, 0 minus 1, 0 minus 2, 0 minus 3. So you can see x is constant at 0. But y is not constant. It can be any real number. So it will be k. So remember this. X equal 0 is the equation for y-axis, and any point in the y-axis is of the form 0, k. Remember this, do not forget. Okay. Similarly, y is equal 0 is the equation for x-axis, and any point in the x-axis is of the form k, 0. Okay. Now let us take x is equal to constant. X is equal to constant, any constant. Suppose let us take x is equal to 3. Okay, x is equal to 3. So plot some points whose x coordinate is 3. Y coordinate you can choose by your own, but x coordinate is 3. Suppose 3, 0, this one. Okay, then 3, 2, 3, 2. 3, 2 means here. This is 3, 2. Okay. Next 3 comma 4. 3 comma 4 means here 3 comma 4. 3 comma minus 3. 3 comma minus 3 means 3 comma minus 3 here. So in this way you can get as many points as you want whose x coordinate is 3. Okay, whose x coordinate is 3. You will get all the points along a straight line. This will be the straight line. Okay, so we are getting a straight line which is parallel to the y-axis. Okay, which is parallel to the y-axis. Similarly, if you take x is equal to 5, okay, you will get a line through 5, this 5, through x is equal to 5, and it will be parallel to the y-axis. Similarly, if you take x is equal to minus 2, x is equal to minus 2, then you have to draw a line through this minus 2 and parallel to the y-axis. So x is equal to constant is the equation of the line which is parallel to the y-axis. Okay, parallel to y-axis. Okay. Now every point, this equation, the equation of this line is x is equal to 3. Okay. So if you take any point in this line, its x coordinate will be 3. Y coordinate is constant. So randomly if you take any point in this line, the general form of that point will be 3 comma y. 3 comma y. X is 3, so 3 is constant here. X coordinate will be 3. But y we don't know. Y we don't know. Okay. 3 comma y. So x given constant means it is a line parallel to the y-axis, and any point in the line parallel to the y-axis is of the form. Sorry, here 3 comma y. Sorry. For this line 3 comma y. For this line 3 comma y, but here it is k comma y. K is a constant. K is a constant. Here the constant is 3, but y is variable. Y can take any value. Okay. So k comma y. So every point in the line parallel to y-axis will be of the form k comma y. Similarly, now if you take y is equal to constant. Okay. If we take y is equal to constant, okay, let us see. Let us take y is equal to minus 2. Y is equal to minus 2. Okay, here. So plot some points whose y coordinate is minus 2, x coordinate is choose by row. So let us start with 0 comma minus 2. This is the point. Then 1 comma minus 2. This is the point. 2 comma minus 2. This is the point. 4 comma minus 3 comma minus 2. This one. 4 comma minus 2. This one. So you can see all these points lie in a straight line. This is the straight line. Okay. Its equation is y is equal to minus 2. Okay. This is the line. So this line is parallel to x-axis. So if y is equal to constant, then it represents a line which is parallel to the x-axis, a horizontal line. Okay. So parallel to x-axis. Now if you take any point along this line, specific I am taking this line, then y coordinate will be minus 2. Y coordinate will be minus 2. X coordinate we cannot see. X coordinate here is 0, here is 1, 0 minus 2, 1 minus 2, 2 minus 2, 3 minus 2, 4 minus 2. X is changing. So x comma minus 2. Okay. X is changing. X is variable here. This is a constant. Here it is minus 2. For other lines which are parallel to x-axis, it can have other values. Okay. So y equal to k. This represents a line parallel to the y-axis. Sorry, x-axis. Y equal to k. This equation represents a line parallel to the x-axis, and any point in this line is of the form x comma k. These four equations are very important. Okay. X equal 0, y equal 0, x equal constant, y equal constant. You have to remember this. Okay. Ready? Now let us go for reflection. Okay? Now let us go for reflection, the chapter. Let us plot some points. Suppose 2, 3, minus 4, 2, minus 4, 2. This is B, minus 4, 2. I am taking 2 points only. Okay. Now what we will do? We will reflect these 2 points. We can take as many points as you want, but I am taking 2 only. Let us reflect this point A in the x-axis. Okay. Don't look at y. Forget this y-axis. Just imagine that this is the point or object, and this is the mirror line. Okay. And the reflecting surface is towards A. Okay. So this image, the image of A, will be formed behind the mirror, obeying the laws of reflection. Okay. Object distance is equal to image distance. Okay. The image is formed as far behind the mirror. The image is formed as far behind the mirror as the object is in front of it by laws of reflection. Plane mirror. Okay. Imagine that there is a plane mirror. The reflecting surface is towards A. So image of A will be formed behind the mirror, so that object distance will be equal to image distance. So where will be the image of A formed? This is 3. You can see this is 3. So 3. So here, this is A'. Okay, this is A'. The image of A, when it is reflected in the x-axis, what are its coordinates? 2, minus 3. 2, minus 3. Now let us go for B. The coordinates of B are minus 4, 2. Let us reflect point B again in the x-axis. Okay, let us see where its image is formed. Again following the laws of reflection, object distance is equal to image distance. So this is 2. You can see this is 2. So 2 here means this is B dash minus 4, minus 2. So what change did you observe when a point is reflected in the x-axis? You can see A moved to A dash, x coordinate did not change, 2, 2. Only the y coordinate is changing. See, 3 become minus 3. Simply sign change. Okay, similarly look at B. There is no change in the x coordinate, minus 4, minus 4. Now which coordinate changed? Y coordinate changed. 2 became minus 2, or minus 2 will become plus 2. Okay, so remember, when a point is reflected in the x-axis, its x coordinate doesn't change, its y coordinate will change. So I am giving the formula here. Mx A, B means when a point whose coordinates are A and B is reflected in the x-axis. Mx means reflected in the x-axis, or x-axis is behaving as the mirror line. Okay, that is y coordinate will change. So the coordinates of the image will be A, minus B. It is very important. Remember this. Okay. So AB will become A, minus B when a point is reflected in the x-axis. Now let us go for y-axis. Let us go for y-axis. Okay. Now let us reflect this point A, whose coordinates are 2 and 3, in the y-axis. So don't look at x-axis now, look at y-axis. Imagine that y-axis is behaving as the mirror line. There is a mirror like this here, horizontally, means standing on y-axis. Its reflecting surface is towards A. So the image of A will be formed behind the mirror, obeying the laws of reflection. This distance is 2. You can see this distance is 2 because x coordinate is 2. Okay, x coordinate means distance of a point from the y-axis. This is 2, so this will be 2. So the image will be formed here. This is address whose coordinates are -2, 3. Okay. Now let us take another point. Suppose -3, -2, -3, -2. This point is B. -3, -2. Let us reflect this point in the y-axis again. So its image will be formed here behind the mirror, obeying the laws of reflection. This distance is 3. You can see. So this distance of the image from the y-axis will also be 3. So the image will be formed here. So here, this point is B dash. The image of B, its coordinates are 3, -2. 3, -2. So what change did you observe? 2, 3 became -2, 3. That means y coordinate is not changing. You can see 3, 3 not changing. Only the x coordinate is changing. 2 became -2. Similarly, see here, B was -3, -2. B dash is 3, -2. So again, no change in y coordinate. -2, -2, no change. X coordinate is changing. -3 became +3. Okay. So when a point whose coordinates are A and B is reflected in the y-axis, its x coordinate will change. -a, b. Okay. So when point reflected in the x-axis, y will change. When reflected in the y-axis, x will change. Now let us go for origin. What will happen if we reflect a point in the origin? Let us take this point A, 2, 3. Okay. We will reflect this point A in the origin. So imagine that there is a mirror facing towards A. Okay. There is a mirror whose reflecting surface is towards A, and that mirror is on the origin like this. Okay. It is facing towards A like this. Okay. So image of A will be formed here behind the mirror. Okay. The image of A will be formed at -2, -3. -2, here. This is A dash, -2, -3. If you join A and A dash, it will pass through the origin. Okay, and this distance will be equal to this distance, obeying laws of reflection. Now see, what change did we get in the coordinates? 2 became -2, means x coordinate is changing. 3 became -3, means y coordinate is also changing. So when a point whose coordinates are A and B is reflected in the origin, both of its coordinate will change. AB will become -a, -b. Remember this. Okay. So these are the 3 formulas which you have to remember. X-axis then y will change, y-axis then x will change, origin then both will change. Okay. Next, I will move to examples in the next part. This part I am simply explaining the concepts. Okay. Next is mx dot my is equal to my dot mx is equal to mo. Now what does this mean? This means if you take a point, any coordinates, first you reflect that point in the y-axis, then you reflect the image. First you will take a point. I will give an example. Okay, I am just explaining. Take a point whose coordinates are AB. Reflect that point first in the y-axis. You get its image. Now reflect the image in the x-axis. You'll get some point. Okay, you'll get some point. Next, take the same point, means original point AB. Original point AB. We reflect that point in the x-axis. You'll get the image. Now reflect that image in the y-axis. You'll get the same point. That means first reflecting in the y-axis and then reflecting in the x-axis is completely same as first reflecting in the x-axis and then reflecting in the y-axis, and that is completely same as directly reflecting in the origin. So all three are same. I will give you just an example. Okay. I'll take this point A, which coordinates are 2, 3. First, what I will do? First, I will reflect the point in the y-axis. Then I will reflect its image in the x-axis. I will get some point. So first y-axis. First y-axis means it will go here. This is y-axis. So this point A will move here. Its image will be from here. So minus 2, 3. Minus 2, 3. This point is minus 2, 3. Okay. So A moved to AS when it is reflected in the y-axis. Now what we will do? We will reflect this image AS in the x-axis. Next target is to reflect in the x-axis. So when this point will be reflected in the x-axis, it will move here, obeying laws of reflection. This is 3. So this will be 3. So minus 2, 3 will become minus 2, minus 3. Minus 2, minus 3. Minus 2, this is A double dash. Minus 2, minus 3. Okay. So this is the final image. Okay. This one. Mx dot my. Now, let us take the same point 2, 3. This time what we will do? First we will reflect in the x-axis, then we will reflect in the y-axis and see where we are getting the image. Okay. First x-axis. So this point A will move down here because x-axis. So 2, 3 will become 2, minus 3. 2, minus 3. 2, minus 3. Suppose I am erasing this one. Suppose I am erasing this one. Okay. Forget this one. Forget this one. Okay. So A will move to AS, which coordinates are 2, minus 3, reflecting in the x-axis. Now we will reflect this point, the image, in the y-axis. If this point is reflected in the y-axis, this axis, this line, its image will be from here. This is the image. So we are getting the same point. Okay, we are getting the same point. Now suppose directly if we would have reflected the original point, this point, in the origin, where will you get the point, or where will you get the image? This 2, 3 A, its image when it is reflected in the origin will be here, the same point. Okay, so all three are same. Remember this. So if you reflect a point first in the y-axis and then in the x-axis, it is same image. First reflecting in the x-axis and then reflecting in the y-axis, and it is same image, directly reflecting the original point in the origin. Okay. So remember this relation. This can be proved also. I have just shown an example. This can be proved also. For example, let us take a point mx dot my, suppose 4, minus 5. Okay. First I am doing this one, then I move to this, then I move to this. Okay. So this will become mx. So let us evaluate this point. Means this point will be reflected in the y-axis without using bracket. We know the formula, we don't need graph. Okay. If this point is reflected in the y-axis, then its exponent will change. By formula, x will change. So this 4 will become minus 4. This will not change. So minus 4 comma minus 5. So 4 comma minus 5 becomes minus 4 comma minus 5 where the point is reflected in the y-axis. Our next target is to reflect this point, the new point, minus 4 comma minus 5 in the x-axis. When a point is reflected in the x-axis, its y-coordinate will change. So minus 4 will remain as it is. Minus 5 will become plus 5. So this is the final image. Okay. This is the final image. When we did this one, mx into my. Now let us go for this one. Okay. My dot mx of 4 comma minus 5. Means first we will reflect the point in the x-axis. So we will get my. Let's evaluate this one. This point is reflected in the x-axis. Then y-coordinate will change. Minus 5 is the y-coordinate. It will become plus 5. So we will get 4 comma 5. Okay. 4 will remain as 4 will not change. Minus 5 will become plus 5. So 4 comma 5. Then this new point is reflected in the y-axis. So x will change. So this 4 will become minus 4. Then plus 5. Both are same. You can see minus 4 5 minus 4 5. Both are same. Suppose we would have reflected in the origin. We would have reflected in the origin. Then MO, this one, 4 comma minus 5. When a point is reflected in the origin, both the coordinates change. So plus 4 will become minus 4. Minus 5 will become plus 5. So you can see in all the three, we are getting the same point. Minus 4 comma 5, minus 4 comma 5, minus 4 comma 5. So all three are same. Okay. So remember this. Mx into my is equal to my into mx is equal to mo. Similarly, mx into mo is equal to mo into mx is equal to my, means reflecting a point first in the origin and then in the x-axis is same as reflecting the point first in the x-axis and then in the origin, and that is same as reflecting the point directly in the y-axis. This can be proved. You can do by your own. Okay. Similarly, my into mo is equal to mo into my is equal to mx, means reflecting a point first in the origin and then in the y-axis is same as reflecting the point first in the y-axis and then in the origin, and that is same as reflecting the point directly in the x-axis. All are same. Okay. Next we have concept of invariant points. Okay. Invariant points. Invariant points. Now what do you mean by invariant points? Invariant means which doesn't change. Invariant means which doesn't change. Means if you take a point and you reflect it in some line, it may be x-axis, it may be y-axis, it may be origin, it may be any line, but its coordinates will not change. Means it will not move at all. Okay. So is there any such point? Purely there is no such point. Okay. A point is invariant or not, that depends on the line in which it is reflected. For example, I am giving an example. Okay. Suppose we will take this point 3, 0. Let us name it A. this point 3, 0. If we reflect this point A 3, 0 in the y-axis, its image will be formed here at minus 3, 0, sure. Okay, that means this point is changing its coordinates. Its image is formed in a different place. Okay, but suppose instead of reflecting this point 3, 0 in the y-axis, if we reflect the same point 3, 0 in the x-axis, the point is already in the x-axis, and if we reflect this point in the x-axis, where will be its image formed? There only, here. This A is address only, so no change. So in such case, we can say that this point is invariant. So you could see that when we reflected this point 3, 0 in the y-axis, it is not invariant. Means it is changing its position. Okay. But when we are reflecting the same point 3, 0 in the x-axis, it is invariant. It doesn't change its position. So remember this, purely there is no invariant point. A point is invariant depending on the line in which it is reflected. For example, this one. This point is invariant when it is reflected in the x-axis. Okay? But it is not invariant when it is reflected in the origin or y-axis. Suppose again we will reflect this point in this line. This line. This is a new line, suppose L1. Don't look at x-axis, don't look at y-axis. Just look at this line L1. Okay? And look at this point A, which coordinates are 3, 0. This point 3, 0 is in the line L1. Now, if we reflect this point A, 3, 0 in this line L1, then where will be its image formed? There only. So, no change. So, again it is invariant now. Okay? So, again this point is invariant when it is reflected in the line L1. Suppose I will take another line, this line. Now this line is parallel to the y-axis, so it will have equation x is equal to constant. I have given this, okay? X is equal to constant means line parallel to y-axis. So this line equation will be x is equal to constant. What is that constant? 3. So if we reflect the same point A 3, 0 in the line x is equal to 3, which is parallel to y-axis and is passing through the same point, then where will be its image formed? There only. So again this point is invariant when it is reflected in the line, this one, suppose L2. Ready? Now suppose if I reflect this point in this line, this is minus 1, its equation is x is equal to minus 1. Don't look at x-axis, don't look at y-axis, don't look at these lines L1 and L2, simply look at this line L3 and this point 3, 0. Look at this line, look at this point and nothing else. Okay, and nothing else. If this point is reflected in this line, its image will be formed behind the mirror. If this is 2, this is 2. Okay, this is 2. This will be 2. This image will be formed here. So it is changing its position. So now is it invariant? No. Okay. So purely a point is not invariant. A point is invariant or not, that we can say by looking at the line. Okay. You can see from this. This point is invariant in the x-axis, invariant in the line L1, invariant in the line L2. But it is not invariant in the line L3. It is not invariant in the line, means in the y-axis. Okay. So from this we conclude that a point is invariant. Okay. A point is invariant if it is reflected in the line that passes through it. These three lines, x-axis, L1 and L2, and we can draw many other lines which will pass through this point. I have drawn only 3. Okay. If this point 3, 0 is reflected in the lines which are passing through this point, like x-axis, like L1, like L2, then it will remain invariant. Otherwise, not. Okay. So we can write it. a point is invariant under reflection in the line or lines. There can be many lines passing through a given point. Okay, a point is invariant under reflection in the line or in the lines that pass through it. Remember this. Okay, I'm taking another example. -1, 2. Suppose this is B. -1, 2. Okay, if I reflect this point B -1, 2 in the x-axis, its image will be formed here. -1, -2 means it is not invariant. If I reflect this point B -1, 2 in the y-axis, its image will be formed here, and its coordinates will be -1, 2. Sorry, this is +1. Sorry. This point B, its coordinates are 1, 2. If it is reflected in the x-axis, its image will be formed here, 1, -2. Means image is changing, means change in position. It is not invariant under reflection in the x-axis. If you reflect this point B in the y-axis, its image will be formed here, which coordinates will be -1, 2. So again changing its position, means it is not invariant under reflection in the y-axis. But if this point B is reflected in this line L3, this line x=1, then its image will be formed there only, no change. So it is invariant under reflection in the line x=1. Okay, so hence you can conclude this one. A point is invariant under reflection in the line or the lines that pass through it. Okay. Next point, same invariant point only. Okay, every point on the x-axis is invariant under reflection in the x-axis. Okay, every point on the x-axis is invariant under reflection in the x-axis. Means if you randomly take any point, for example 5, 0, 3, 0, -2, 0, -4, 0, like this, you can take any point in the x-axis. If you reflect those points in the x-axis, there will be no change, so they will be invariant under reflection in the x-axis. Okay, so remember this point, every point on the x-axis is invariant under reflection in the x-axis. Similarly, every point on the y-axis is invariant under reflection in the y-axis. Remember these 2 points. Every point on the x-axis is invariant under reflection in the x-axis. Every point on the y-axis is invariant under reflection in the y-axis. Third point, the last point of this part. Origin Origin means 0, 0. This point is invariant. Under reflection in the x-axis, y-axis and the origin. If you take this point 0, 0, if you reflect this point in the x-axis, it will remain invariant because it lies on the x-axis. If you reflect the same point in the y-axis, again it will remain invariant because it lies in the y-axis, no change in position. If you reflect this point 0, 0 in the origin, same point, then again it will remain invariant. Okay, for that reason I have written here the origin of 0, 0, this specific point, special point, is invariant of the reflection in the x-axis, y-axis also, and the origin also. Okay, so I hope you have understood this part, the basic concepts of reflection, part 1. In the next part, I will move to examples. Okay, so thank you for watching.